Okay, so I think yeah, desktop is presentable to all of you. You can see it. Yes. Hello.
Yes, sir.
Okay.
Yes, sir.
Okay. Then let me go back again, and here I will have to double click on this. Okay, we are over here, and we'll see the HRB. Okay. This was whatever we were doing. So I was deleting this, and right now we are at second floor. Yes, can you see all of you? Hello.
Yes, sir.
Yes, sir.
Okay, okay. So let us move one by one up. So it is clear up to at slab, I think. 11th, 12th. Okay, that has been also deleted. And you can see finally at this staircase cap, there will be a slab over here, and there will be a slab over here. So now this is correct, I think. So we'll save it. Okay. Now, previously I might have analyzed, but today we'll just go back and under load cases, we'll see that response spectra and will modify and showcase. And under that, this I will change as 1000. Similarly for spectra Y, I will go and see and I will make it 1000. Right.
Yes, sir.
So, and then if I change anywhere else, so let us see whether we have applied. Yes, the diaphragm is applied and it is D1. So everything is now ready as per our choice. And now you can see you just have to go to analysis. Under that, you have to check the model and select this so that everything you will select it and click OK and see that model is correct and there are no error messages. And if the error messages are there, you will have to rectify those error message with proper. I think we have done that also. Let us see what the decision will be given by now. Now you can see the model is big, and that's why it is taking a little bit longer time for checking it. And you can see over here the checking process is going on. Okay, so analysis model. Okay, so there are model has been checked and no warning messages are there. That means now we are in a position. Then one more thing that you can go and check here under model cases. You can click on that and you can see here we have asking to go for 100 number of modes, right? Click on that, click on that. Okay, now we'll analyze the model by going to analysis, and you can check the activity load cases to run. So you can check it over here and see this action. So all these are all primary load cases, and you can see whatever load cases that you have created will be seen over here, and you can see everywhere. Right now, the status is not run because we have not analyzed it. That's why status is not run, and he is giving you information about action. Here, you can put some cases not to run. In that case, it will not run those cases, right? But right now, you can see, if you are not interested in finding wind cases, you can check it over here, and you can click on this, do not run. You can click on this, do not run. Okay. So wind analysis, you are not carrying, you are carrying only uh, earthquake analysis, because EQX, EQY, response spectra X and response spectra Y are under run action. Clear?
Yes, sir.
And then you can say run now. So now it will run the entire analysis procedure. It will apply IS code, because we have asked him to uh, go for codal provision. So earthquake analysis 1893 will be applied for this, and then you can see under design, he will use those codes. Okay, for analysis we don't need any code, because analysis is just a simple uh, for calculation of stresses, maybe external forces, maybe shear force, bending moment diagram, torsional moment, then stresses, maybe axial stress, shear stress, and flexural stress. All that analysis will be carried out, and you can check. It is taking a little bit time, and that is okay, but it will not. You can see over here now it is running the analysis, and this green will give you the extent of analysis it has carrying. Now you may say that maybe 2 3 minutes more, or maybe 5 minutes. Okay, so that process, I just wanted you to go through this. Otherwise I could have analyzed and directly shown you the analysis results. Clear, or
Yes, sir.
any
Yes,
doubt?
sir.
See, you also have to do the same process, and during that you should not have any confusion. That's why I am carrying. Otherwise, we could have saved these 5 minutes by directly pre-analysis the things and showing you the results. But that the I don't wanted that gap. That's why I thought that it is better to invest 5 more minutes. That doesn't matter. And I think I'm right. Or you wanted,
Yes, sir.
yeah. See, it will take a little bit time more. And after this first run, so this is called a first run. After this first run, first we'll go and check the base shear that is calculated by EQX, EQY, then base shear calculated by Spectra X and Spectra Y, and then we'll check that, and we'll rectify the scale factor, and then again we will have to reanalyze, right? So two
Yes, sir.
times, at least two times. But that will clearly give you idea how you can correct the base shear, dynamic base shear, how you can scale it up to match with equivalent static load method base shear. Okay, now during that time, if you have any queries, you can ask me, because it is going to take a little bit time.
सर
Yeah.
सर जनरली सर अगर हाई राइज बिल्डिंग अगर 45 मीटर से ग्रेटर हो तो सर तब विंड लोड एनालिसिस करना पड़ता है ना सर
Yeah, करना पड़ेगा.
प्रैक्टिकल
Yeah,
प्रैक्टिकल
करना
सिनेरियो
पड़ेगा.
में
Yeah, yes,
यस
the process is same. I only why I have not gone through that, because later on you can keep that also to run, and you will directly run the entire building for response spectrum. I mean earthquake analysis as well as wind analysis, and whatever may be the worst condition, you will design the building for that. But normally that wind is active after 50 60 meters. I mean,
यस
wind is active, but uh, it is not it is not worst combination. because the entire control will be control the behavior of the building will be controlled by earthquake activity. But you can apply wind, and you can check, and you can find uh, which one is the controlling factor, either wind or earthquake.
Yes, sir.
Yeah. Any other query? That's nice. That means you are doing some exercises also. See, उन्हीं लोगों को डाउट आएंगे जो काम कर रहे हैं. अगर आप डाउट नहीं पूछ रहे तो मेरे मन में ये डाउट रहेगा कि शायद यू आर नॉट वर्किंग, और यू आर नॉट टेकिंग स्ट्रेसेस ऑन योर ओन. Just watching will not give you a right thing that you are interested. You have to work, and you have to work sincerely, and you have to invest the time. You have to read the books, all those books related to earthquake behavior and related to wind load behavior. You have to go through uh, codal provision for wind as well as uh, seismic analysis. So now that has been completed. Now you can see this is the time, and this time depends on the strength of your laptop or desktop, whatever you are having. You can see uh, the it is now, it is giving you start animation. But now, before going to start animation, I will go and see. The first thing is this. I will make it again that, and I will check the results. And how I can check the results? Go to display.
Display.
Under
Okay,
display,
sir.
go to show tables. Under show tables, go to analysis. Under analysis, go to results. And under results, first I will go to reactions, and then base reaction, and then I
Oh,
will click OK. So that base reactions will be given to me, and now these reactions will be given for all cases and combination also. So you will see. Uh, so this is, you can check it. How many? So this is table 1 of 52. So the analysis tables are something around 52, and you are viewing that. And now you can see for every load combination and for every primary load cases, you are getting the results. Now all these results, right now you are not interested, so you can click on this, you can right click on it, and then the filter will be available, and then just go like this and see your primary load cases. So where are your primary load cases? Your primary load cases are, yeah, so here are your primary load cases. Now I will press Control, then I will click on EQX, I will click on EQY, I will click on Response Spectra Max and Response Spectra Y, and now only these will be made available. And now you can see this is due to earthquake in X direction, you are getting base here equal to 2784.1008, and due to response spectra, you are getting 1167.0541. So now the first thing is that, does VB is greater than VB dynamic? Yes or no?
yes, sir.
कैसे, ये माइनस है, ये प्लस है?
सेम नहीं है तो
यस.
हमको अर्थक्वेक से डिवाइडेड बाय सर रिस्पॉन्स स्पेक्ट्रम से डिवाइड देंगे फिर और
This
इसे
is,
मल्टीप्लाई
see, this is minus 2784, and this is
सर
plus 1167. So which one is greater?
EQX.
nahi response factor, because it is positive, EQX is negative. So negative is positive is always greater greater than negative. See, मैं कंफ्यूजन क्यों क्रिएट कर रहा हूं, क्योंकि ये कंफ्यूजन अगर आपको बाद में आया तो देयर विल बी नोबडी टू आंसर. Now let me clear you that in the results you don't go for negative and positive, you just go for magnitude. Why it is negative? Because you have applied earthquake in x direction. That's why base reaction is in negative direction. Okay. And why you are not? You may say that, sir, dynamic analysis is also we have not said anything. But now you can see here he is saying response spectra max. That means if it is applied from left, it will give you reaction in opposite direction. That is, then it will be minus. And if you apply this in negative direction, then it will give you a reaction in positive direction. That means this is max. That's why you don't have to go and consider this negative sign. Just consider the magnitude. So if I consider magnitude 2784 is always greater than 1167. That's why EQX is more than spectra X. So base shear that is applied or that is the building is subjected to resist is in equivalent static load case is more than dynamic base shear. Clear?
Yes, sir.
Okay. Now either you can right click on this. Okay. You can right click on this and you can copy. Okay. You can copy these results and you can save it somewhere of your choice. Let us say uh, I will save them in Excel sheet. So I am opening Excel sheet and I am saving it somewhere here. So I will paste it. Okay, clear?
Yes, sir.
Yes, sir.
Then I will put down it. Then I will reopen this. And now I will close this. And now I want to make a correction in the scale factor. And for that, what I have to do, I have to unlock it. Now unlocking will delete all the results. That is okay. Because unless you unlock it, you cannot edit that scale factor. Now you are going to define, and under define, you are going to load cases, and under load cases, you are going to response spectra X, modify, and now here, what you will do? You will multiply. So multiply. Yeah, what is happening? Okay, shift and star. So multiplying by 2784.1, or let me write it like this. Okay, so 2784.1008. So I will write that 2784.1008.
8.
Okay,
Divided
divided by
1167.05.
Okay, 1167.0541.
Sir, 1167.05.
1167 0.05, and what is that?
4-1.
4.
4-1.
Okay.
1. Yes, sir.
Okay. So now I will just enter, and you
So,
can see immediately I'm getting the scale factor. So I don't have to do it manually. Clear?
yes, sir.
2385.58. Then click OK. Similarly, click on response spectra Y, go to that, then go over here. So 1000 multiplied by this, what is that?
1157
1157
82.
all four digits, you consider all four digits. So 1557.8161, right?
Yes, sir.
So what is that? 1157
5-7.
point
8161.
8161.
8161 slash
1031.
1031
Point
point
779.
779
98.
98, and then I
Yes, sir.
enter. So now he is giving me 1122.15. Okay. So now this is the first step that you have to do, so that here what we have done, that we have scaled up all response quantities of dynamic base shear with that static base shear. And the meaning that, we have gone through that PPT where
Yes.
I have given you in detail why it is to be scaled up. Because in one case we are finding out VB with the help of earthquake character, and in another case, that is dynamic, we are finding out VB based on actual distribution in at every floor level. Now that actual distribution at every floor level is to be scaled up with that, so that your analysis will be more precise and more conservative, right? And why this is to be carried out? Because everything is approximate. Clear?
Yes, sir.
Yes, sir.
हाँ, लोगों का ये फंडा क्लियर नहीं होता है. I have seen many times. Again, go to analysis and run the analysis. ये दोबारा करना पड़ता है, इसको कोई दूसरा solution नहीं है. So again, we'll have to invest that much time. It has started creating analysis model. So now what is meaning by this creating analysis model? Anybody know? जितना डीप में जाओगे उतना ज्यादा कॉन्फिडेंट बनेगी. See, the creating analysis model now loads, then constraint, everything. Now the analysis model is prepared, and now it is going for analysis. See, there is a process in software, every software. Whatever model that you find that you have created is object-based model. That means you have created the objects. Now those objects are converted in finite element method, and that is analysis model. So first, this object-based model is converted in analysis model. Only then any software can work on that, and then it will analyze the model and get the results, and those results again reflected on your object-based model. So that is the process that is carried out while you see this green analysis. Why it is taking time? Because whatever you have given him column, but he doesn't understand column. So the column is converted in analysis model, which is made up of finite element slabs. Every slab is converted in finite element base. So everything is converted in that, and that finite element analysis, there is a algo that is built in every software, and that algo is based on finite element analysis methods. Now, if you want to see all those, you will have to go through finite element analysis. जाएंगे? See, that is a deep knowledge, and it will take a lot of time. But if you invest some time in understanding what is a finite element method, how it has been approximated, then all these errors and the system behind or the procedure behind detecting those errors, that will you will be benefited with that. Otherwise, don't worry, software will take care of your object based model. It will convert in analysis model, then again it will analyze, and it will give you results in your object based model, which you know. I think many of you might know this. Yes, Samir, do you know?
यस सर, उसमें एक्चुअल में सर आपने वो जो डॉक्यूमेंटेशन पढ़ने को बोला था ना मैनुअल रेफरेंस में, उसमें पढ़ा था सर मैंने। उसमें सर ये दे रखा था कि मैशिंग करके फिर मतलब ऑब्जेक्ट बेस्ड मॉडल को एलिमेंट फाइनाइट एलिमेंट में कन्वर्ट करता है, फिर वहां से रिजल्ट को उल्टा कंबाइन करके फिर वो शो करता है।
Right, right. So that's why I have given you the some hints that go through that help model, go through that help and analysis reference manual. So there he has given you each and every aspect. Nothing is hidden from you. So this is the quality of this software. ये सॉफ्टवेयर ऐसा कुछ नहीं है कि आपको जादू, वो बोलते वी हैव नॉट डन एनी मैजिक, we are simply running on proven methods of analysis. Yes, Vinay, you are knowing this or not? Hello,
Yes, sir.
Avinash, Vinayak nahi, Avinash. I was misinterpreting your name.
It's okay, sir.
Yeah. Finally, you got it that I am talking to you. Even if I said Vinayak to you. Anyway, this is now you can see everything is now the animation, and now you just have to check it. So I'm clicking in this, then I'm going for undeformed positions, and then I'm clicking in left window and go to display, show tables, and under show tables again we'll see that table which we have copied, and you can find the result. Now you can see 2784, 2784, then 1557 and 1557. Clear? Okay.
क्लियर सर।
Yeah. So
सर सर
yeah.
मुझे पूछना है सर, ये अगर इन केस एफ का जो डिजिट दिया है उसमें और एफ वाई का जो डिजिट दिया है उसमें अगर 10 से 20 डिजिट डिफरेंस रहे तो चलेगा ना?
चलता है, अगर वो आपने लिया तो भी चलता है, मगर सी whenever you are submitting, see if this is 2784 and this is something around 2780, even then it is okay. उससे बहुत ज्यादा फर्क नहीं पड़ता. बट इफ यू वांट टू प्रोवाइड, वन में आस्क यार कहाँ ये अलग है, ये अलग है.
तो वही मतलब वही पूछना था सर कि 10 डिजिट का डिफरेंस चलेगा ना, वो वही पूछना था.
या सी या नो प्रॉब्लम. वो सी फॉर एनालिसिस यू डोंट हैव टू वरी अबाउट इट, बिकॉज उससे बहुत ज्यादा फर्क नहीं पड़ेगा. बट अगर फैसिलिटी है तो क्यों नहीं यूज करना है.
नहीं नहीं, वो ठीक है सर, मत मुझे बस एक कंफर्मेशन चाहिए था कि ये चीज अगर इन केस कभी मॉडल में होता है तब उसके लिए फिर क्या
वही
करना।
होता है ना, see, if you are not using these 4 digits, and then your scale factor will change, and that scale factor will not after that using that another scale factor, you if you go for this result, here again you will find the difference between EQX and Spectra X, or EQY and Spectra Y. So if some difference you if you accept that, then it is okay. But if you don't accept, then you will have to go with 4 digits.
ओके सर।
Normally लोग इतना ध्यान नहीं देते. Normally बोलते हैं ठीक है 2784 divided by whatever was earlier. So earlier say let me open. See 2784 divided by 1167. अगर आप वो फैक्टर निकालोगे तो it will be different than whatever we have calculated. And if you apply that, then there will be a slight variation in the result, but that is okay. If you are happy, then software is happy. Clear?
क्लियर सर।
अगर आप बोलेंगे नहीं 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 मुझे एग्जैक्ट चाहिए, तो सॉफ्टवेयर बोलेगा वो फिर मैंने जो एग्जैक्ट दिया है वो ले लो ना. आप अप्रोक्सीमेट लेंगे और मुझे एग्जैक्ट मांगेंगे, ऐसा नहीं चलेगा.
नहीं वही चीज था, क्योंकि एक दो मॉडल मैंने जो एनालिसिस किया था तो 2784, तो उसके यहाँ पर मैं 2782 83 इस तरह था, डिफरेंस 4-5 डिजिट का था, 4-5 नंबर का सर, तो
हाँ
इसीलिए मैं पूछ रहा
नहीं
था
नहीं
आपसे।
बराबर है ना. you have not used 4 digits after that decimal for calculation of your scale factor. That's why that difference is coming. But that is okay. That doesn't make much difference in the final results.
ओके सर।
Yeah, that is acceptable. But I know this procedure. That's why I'm telling you that you can get the exact result in the analysis itself. Exact means, again, I don't know exact result, because nobody knows the exact result. कितना कितना अर्थक्वेक वहां पे आने वाला है, उसकी वजह से कितना बेशियर रेजिस्ट करना पड़ेगा, उसका ये जजमेंट है. सो आई विल से दैट if you are getting 5 digit away from my judgment, then your five digit or 5 numbers away from the exact, while I am near than you. That is the only way, because exact किसी को पता नहीं है. Okay.
ओके सर।
Yeah. Now we'll go and see. Okay. First, let us go to display. Then go to show tables. Now under show tables, I don't want this, so I will click on this, and I will go in model results. So I will click on that. Under model results, I will go for model period and frequencies. Let us see that. Okay. So how many model results, model periods you will get?
100 से लिए थे सर।
Okay. As you have asked him 100, he will go for 100. Right?
यस सर।
But that doesn't mean that always he will go for 100. Let us say that let us say after 20 modes, entire model mass is absorbed. Then he will not calculate more than 20, even if you are asking 100. और यार 20 में ही खत्म हो गया ना, मैच ही जल्दी खत्म हो गया, 5 डे का था मगर वो एक दिन में ही खत्म हो गया. Clear?
क्लियर सर।
Now that is the first possibility. Second possibility is that even if after 100 you won't get that 90% model mass. In that case, again you will have to go back and increase the number of modes with your judgment and reanalyze it till you get 90%. Clear?
सर एक चीज पूछना था इसमें, मॉडल मास हम लोग एक फ्लोर पर 2 लेते हैं, मोड लेते हैं 2 एक फ्लोर पर, तो इस पर वाटर टैंक को भी ऐड करेंगे या सिर्फ लास्ट रूफ रहेगा वहां तक सर?
नहीं नहीं, we are analyzing up to terrace because whatever load is above terrace, it has been already calculated, already transferred on the columns. So जरूरत नहीं है. You can go for top of roof. See, again, that is your choice. You can go to from base equal to ground to LMR top, because that is what you are giving through your define statement, right?
राइट सर.
Now let us see. So the first mode, you can see your first mode is having a period of 2.26 seconds. Clear?
यस सर.
And
Yes, sir.
you can see this eigenvalue is 7.7298. So if you find a square root of this, you will get answer equal to circular frequency. Okay, because this square root of this will be this circular frequency, and 2 pi upon omega will be your time period. Clear?
क्लियर सर.
Clear, sir.
Okay, then so the first mode you are having, and you will always see that first mode will have a longest time period. Okay, you can see it is in ascending, descending mode. Okay, after 2.26, you are getting 1.874, then 1.805, then 0.633, then 0.55, then 0.50. So it is always, so the maximum. So the longest time period will be considered as mode number 1, and that's why we say mode number 1 is your fundamental mode. इतना clear हुआ?
Yes, sir. Clear.
तो ये clear होने के बाद इसका, okay, I will close this. Now I will go for okay, first उसके पहले we'll see that, and then I will explain. So go to display, go to show tables. Under show tables, I will uncheck this, and now here I will go for model participating mass ratio. Click on this, and this will be very important result for you. Now, what is the importance of this result?
तो कितना मास एक्टिवेट हुआ है सर, वो शो करता है.
So that will give you whether you are going with a right configuration or there is some changes that you must go. Now the first thing is that you can see a first mode where you are having UX. Now this UX means this is a mass getting contributed when the system is subjected to mode number 1 with time period equal to 2.26. So a vibratory mass in X direction is 0.0074. That means 7.4%. इतना clear हुआ?
यस सर.
Then UY means this is the total mass or percentage of total mass, or you can say fraction of total mass that is getting activated in first mode in translation in Y direction. Clear? And how much it is?
Yes, sir.
65.
0.6507, that means 65.07%.
65%.
So which
Yes.
one mass is more, either UX or UY?
UY sir.
UI.
Because here it is 7.4%, here it is 65.07. That means 65.07% mass is getting activated, or that much energy is absorbed during mode number 1, and it is in through a dissipation in Y direction.
सर कितना मास ये एक्टिवेट होना
आगे
चाहिए?
चलेंगे ना, आगे चलेंगे, 1 by 1 एक देख लो.
ओके
Okay.
सर।
Now sum ux. Now this sum ux means total mass contribution up to that mode. Now we are in first mode, so up to that mode will be just like this, and this will be just like, so sum uy will be just like this, right?
राइट सर।
We have not analyzed in z direction, so z uz and sum uz, you will always get zero unless you go for earthquake in z direction, that means vertical direction. Now this rx ry, do not go into that, but see this rz. And what is rz? 0.008. That means 0.8% mass is getting in a rotatory mode about z axis. Okay.
यस सर।
यस सर।
That means very less mass is getting contributed while the first mode is vibrating or rotating about z axis. Now we'll see that. So whatever we have analyzed with the help of our table, let us see whether we are getting the same thing in this, right? So let me go to a sign, clear display of a sign. Okay. Uh, now I'm going in display under deform shape. I will click on this deform shape. Then I will click on mode and I will ask him, show me the behavior in mode number 1. And what is that we have understood from our table, that it will deform in a translatory mode in y direction, because 65% mass is getting contributed in y direction, while there will be very less torsion about vertical axis. And let's see the same we are getting over here. So start animation. थोड़ा थोड़ा वो एनिमेशन के लिए भी it takes a little bit time because this model is a little bit high, and you can see it has to vibrate in y direction
यस सर।
without or very little torsion. हो रहा है?
यस सर।
And this is your first codal provision, that you have to either in x or in y. Now if you see the configuration of the entire building, you will definitely see that the building is flexible in y direction. That's why the first mode will be always in y direction. And if you are not providing proper sizing of columns or proper configuration of these vertical walls, then this wall and this wall or these walls, then the building might be in torsion. So in that case, the building might rotate. But now you can see very, very less rotation because 0.6%.
सर।
Clear?
क्लियर
यस
सर।
सर।
Okay, so this is very important. And यही यही आपको किसी YouTube पर नहीं पता चलेगा. Okay. वो
यस
बस
सर।
वो दिखाएंगे, ये ऐसा बनाओ, वो स्टेयरकेस ऐसा बनाओ, वो सर्कुलर स्टेयरकेस है. कुछ फर्क नहीं पड़ता सर्कुलर स्टेयरकेस को. You convert it in loading and do not create it. Doesn't matter.
आप कंप्लीट कर दोगे सब पूरा ये टैब, तो मैं यूट्यूब चैनल बनाऊंगा एक, उस पर मैं वीडियो बना के डालूंगा।
या क्या बोल रहे?
सर आप कंप्लीट कर दोगे ना पूरा, तो
हम्म,
फिर मैं एक यूट्यूब चैनल बना के उस पर वीडियो अपलोड करूंगा खुद का, अलग से
कर लो
एनालिसिस
कर लो
करके।
कर लो, बहुत बढ़िया है, बहुत बढ़िया है. कुछ करो, लोगों को भी दिखाओ जो तुम्हें समझाए। और
Yes.
चाहे तो उसके पैसे भी ले लो, कुछ फर्क नहीं पड़ता। पीपल आर रेडी टू पे प्रोवाइडेड यू आर गिविंग प्रॉपर इंफॉर्मेशन। बराबर?
Yes, sir.
Okay. Okay, then we'll go and see the display. Display, show tables, and just the same table. Now you can see under mode number 2. Under mode number 2, now the period is getting reduced, and here UX you are getting 0.0873. That means 8.7% mass is getting activated. UI, you will see very less mass getting activated in translation in Y direction. Then some UX, you will see a sum of this and this will be this, right? Sum UX means it is a summation of total mass contributed while the system is vibrating in X direction up to that mode. So first and second, up to second. So in first mode, it is this. In second mode, this is. So sum will be sum of this, and that should be equal to this. You can check that. Similarly,
Oh,
this plus this will be equal to this. Okay.
Yes, sir.
Now forget about Rx, Ry and see this. Now your Rz is getting 0.5328. That means your building will be rotating in torsional mode, because now the mass, that mass contribution in rotatory mode is 53.28, and that you can again look into that. So if I go in display and deform shape, where is that deform shape? Now instead of 1, I will say that give me in 2. So now you will completely understand what is a torsional mode. Clear हो रहा है? So it is
Yes, sir.
rotating about Z axis.
yes, sir.
Now, if the building will rotate about Z axis in second mode with 53.25, something like that, percent of mass or seismic mass, who will be under stress? Columns, walls, or slabs and beams? Who will be under stress?
Beams and slabs.
Why? Or who is getting twisted? Columns or
Columns.
vertical members? नहीं समझता है तो ये देखो।
आ गया सर, समझ आ गया।
आया ना? Now code does not allow you to go in this way. That means you have to make some changes in your configuration. Either you have to add some bracing over here, somewhere here, or you have to revise your layout. Whatever you want to do, you can do. But code says that second mode. So actually, code says that first and second mode. These are the basic modes. These two modes shall not be under torsion. और फर्स्ट में तो किसी भी हालत में नहीं, सेकंड में अगर टॉर्शन है, so code has given you some basic things that code says that up to 20% mass agar hai, that you can ignore, but not more than 20. And how much mass we are getting over here? 53. So very high than codal provision. So in that case, you will have to do something, either so that this torsion will be arrested. And why this torsion is coming? Because instead of this, if I had a column over here or a column over here, and I could have joined it, that torsion could have been neglected. Or or I will have to create some sort of bracing system over here, over here, so that that torsion will be nullified. Or I can remove this. Let me show you. I can remove this wall and this wall, and I will place 1, 2, and 3 parallel walls only. Are you getting it?
Yes,
तो
sir.
ये आप लोगों को मैं प्रोसीजर देता हूँ. So this model, or you can create the model yourself, and later on, first create the model with this E-type wall, and then uh, remove this wall and this wall, and reanalyze with modified scale factor, and you will see that that second mode is also under torsion is removed, and now the second mode will move in X direction. Okay.
Yes,
Okay,
sir.
sir.
Yeah. So that is, but frankly speaking, code will not allow you, or that means, see what code can guide you. Code cannot do. You may be having, and in fact, we have asked the builder to remove this wall and this wall, and then finally he said, okay, we will do that. But architect was not prepared for that, and he used to give his problems, that problem of that fire security, fire system requirements. But finally, he agreed, and we have removed, and you can check that. I'm not giving you that directly, or you can add a wall somewhere here, but here nothing you can do, because this is your driveway. So here you cannot do anything. That is sure shot. So what, either you can create a wall over here and a wall over here, so that it will give you additional resistance against the torsion. So all those things you can see, and then you can understand how the codal provisions are met, right?
Yes, sir.
Then again into that, now the third you can see, now the third, you are having 57.89. That means third mode is vibrating in X direction, right? UI is less, so it is not. Then some UX you can see up to third mode, your some UX is coming out to be 67.36, and some UI is coming out to be 65.9, and RZ in third mode, you can say again 10%. So 0.1024. So 10%. So you can check now. Okay, we'll do that also. So let us see that. Go to display, under deform shape, under this, and apply. So now the building should deform in X direction, in translation mode, and maybe a little bit torsion, because in torsion also the building is having 10% mass contribution. क्लियर हो रहा है?
यस सर।
इतना भी आपका क्लियर हो गया ना तो मैं कहूंगा बहुत बहुत कुछ सीख गए आप. Because people do not know this also. Lot of people are there, they are creating the model but they don't understand anything about model. और क्रिएशन इज वेरी सिंपल. क्रिएशन में कुछ ज्यादा मेहनत लगती है क्या? मुझे मुझे नहीं लगता कि है. कुछ
नो
भी
सर।
डाल दो ना. You just have to understand what is the command, how it is operated, and you can create anything. But whether that is suitable as per our codal provision or not, and if it is not, how to rectify all that. For that, you need to go through seismic behavior. Okay, then again show tables, and under that, now I will show you. So the third mode, you can see up to third mode, you are getting 65. And one more codal provision is that up to first three modes, at least 65% of mass should get in, or 65% mass should be absorbed in some UX and some UI. And you can see that we are following. So in UX, we are getting 67%, and under UI, we are getting almost 66%, right?
यस सर।
And you have to cross check the codal provision and you have to compare it with your results. Then the final code also says that the difference. So the first mode is 2.26, time period is 2.26. This is 1.87, 874 and 1.805. And code also says that the modes should be well separated from each other. That means the difference between the frequency, either you can say frequency or you can say time period, well separated means the mode should be at least 10% away from the lower. So what is the lower? 1.805. And if you find out 10% of that, how much it will be? 0.18. Okay. So if you add 0.18 into that, then this mode must be higher than whatever you have added. And you will see that this does not match. Actually, that is a something vague concept has been, or code was not specific enough. Uh, Actually, code want to say that, see, first mode is in translation in Y direction. Okay. Yes or no?
यस सर।
Now, the second mode, which is in translation in Y direction, will happen to be fourth, because no, not even fourth. Uh, it will be something 55. No, so yeah, it is fourth, because in first mode you are getting 65.07% of mass contribution, and in fourth you are getting uh, 11.64% of mass contribution. That means the difference between this and this has to be more than 10% of the lower. Are you getting it? So people are confused. They say that adjacent modes. So adjacent modes in same direction. Okay. So if I consider mode number 3, which is translatory mode in X direction, then the next mode, which is in translation in X direction, I will have to find out, and it will be this, right? 0.07 means 7.16%, right? So then second and third and sixth, I will compare third and sixth. Frequency of third is, or time period of third is 0.509, and this is 1.8. So it is well separated. Got it?
यस सर।
थोड़ा थोड़ा इनिशियली डिफिकल्ट लगेगा, मगर जो है वो है। आपको यू विल हैव टू रीड कोडल प्रोविजन अगेन एंड अगेन, मे बी 10 टाइम्स, 20 टाइम्स और 50 टाइम्स। मैंने अब तक कम से कम 100 टाइम्स पढ़ लिया है, तो आप कम से कम 10 बार तो पढ़ना चाहिए कि नहीं?
यस सर, पढ़ना चाहिए।
हाँ, और अगर नहीं नहीं समझता है तो राइट डाउन whatever the codal provisions are shown over there, just copy it, write down, and then try to find the meaning between that. And this was confusion with 1893, but which has been cleared in 1670. So that is a special code for high-rise buildings, uh, and 1893 is applied to all buildings, while 16700, that code is applied specially for high-rise, and in that code has clearly shown that. So third and sixth. So if I compare third and sixth, then it is okay. If I compare first and fourth, then you can see, and that will be decided with this UX and UI. Okay, so this is UX UI. So the first mode is in Y direction, and you can see fourth mode will be also in Y direction, and that RZ is almost nil, and that you can verify. You can verify graphically also. Let's see how. So I will close this, and I will go to this again, display, deform shape. So for fourth, so this fourth mode again will be in Y direction. सबसे difficult part is this analysis of the model. अभी तक आपको क्रिएटिंग द मॉडल डिफिकल्ट लगता होगा ना? Is it in Y direction?
Yes, sir.
यस सर।
Yes, sir.
And what is the shape? See, if I draw the first mode, which was in Y direction, it was something like this. ये ऐसा मूव कर रहा था ना?
Yes, sir.
And if I draw this mode, it is moving like this. है?
Yes, sir.
Yes, sir.
तो अभी पता चला मोड शेप का कैसे कोरिलेट करना है.
Yes, sir.
ये आपको किसी ने बताया अभी तक?
एक बार आप ही ने बताया था.
एक बार मैंने बताया था.
जी सर.
Okay, now we'll see, we have seen a third mode in X direction. Now we'll see a sixth mode in X direction. Because in that table, we have seen that sixth mode is also vibrating in translatory mode in X direction. टाइम लेते हैं यार, वो भी थक जाता है. पता यार क्या क्या पूछते हो. Yes.
Yes, sir.
And but there is a little bit torsion which you can ignore because it is not a pure translation mode. It is a little bit mixed with torsional mode, but torsional contribution is very less, so you can safely ignore. And you will never get ideal situation, but because in ideal situation you must get a rectangular shape building, so that is not possible. But this will clear lot of ideas about that. So how you can look into the table, and how the table that you are looking will be seen. Okay, so this way you will analyze each and every mode. I will say that go ahead and find out the behavior of each and every mode, because here you are going for 100 modes. Now, why we are going for 100 modes? Because one more situation is that some UX. So you have to find some UX up to 90%. That means something about 0.90 something. So if you see over here, you're getting 88, 88, 88, then 887, and here you are getting 89, 89, 89. Yeah, this. So you're getting your sum UX up to 91. Clear?
Yes, sir.
Sum UX, you can say 89.72. Again, it is less than 90. So I can say that up in the 91st mode, you are fulfilling the codal provision that sum UX should be at least more than 90%. And now you can see one more observation. You can see, uh, see your third mode was 67%. Okay, then immediately you can see your 12th mode is 83%. But from 83 to reach to 90, you have to go from 12 to 91. And you can see in each mode, the contribution is increasing very small amount, right? And that is why most of the time we are truncating. So you can say that you can truncate it up to 6, or you can say up to 20. Let's say up to 20. So because after adding so many modes, you're not getting much benefit, because now the increase of mass contribution is very less. As you are increasing the number of modes, nothing is happening. You can check it over here. Nothing is happening under UI also. And this model 23rd mode is not at all having any contribution in X direction, and it is having only 1.7% contribution in Y direction, right? So that is also answer why you can safely go up to 20, and you can say that rest of the things are just academic purpose. Practically, it has nothing to do, right? See up to this mode number 20, I'm getting 85.90, almost 86, and code says that 90%. So only 4% margin is there, and here I'm getting 88. So some UI I'm already near to 90%, and here I'm just a little bit away from 90%. So I can say safely I don't need additional modes. I can go for only up to 20. But if you want to fulfill all codal provisions, that's why we have carried out the part up to 90, 91. So you can say up to 91. Now, this 91 already, this mode number 91 is fulfilling the codal provision over here as well as over here, right?
Yes, sir.
Yeah.
तो सर
And,
जिस
yes.
सर मतलब इसका मतलब ये हुआ कि हम लोग को या तो सारे बिल्डिंग में मोड नंबर सब सारे बिल्डिंग में मोड 100 लेके चलना होगा.
No, that depends on the configuration, not always. Many times the codal provision are passed up to 10 mode only. Even you don't have to go for 12 modes. That depends on what type of building you are analyzing. Very complex, irregularly shaped. The prediction of the earthquake behavior is very uncertain. कुछ भी नहीं है, कब क्या होगा पता नहीं. So under such complicated things, you have to go for more than 20 modes. But even then, see this is actually a complicated building. Complicated because it is uh, having number of openings and the corners are not tied properly. Otherwise, the building is simple. But from the consideration point of earthquake behavior, the behavior of the building is complicated because of number of complications that architectural plan has created. But even then, you can see you can stop at 20. क्योंकि आगे जाके आपने क्या अचीव किया? Only 4%.
तो सर वो 85% में बिल्डिंग सेफ है.
हाँ
20 मोड लेते हैं तो उसमें 86% अप्रोक्स आ रहा है, तो वो बिल्डिंग सेफ होगा.
वैसे तो कोई भी बिल्डिंग सेफ नहीं है भाई.
तो मतलब इसमें ये सोल्यूशन हुआ कि सर ये कोडल प्रोविजन के अनुसार हर समय सही नहीं होगा.
नहीं 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 नहीं, नहीं ऐसा नहीं. डोंट कम टू द रॉन्ग कंक्लूजन्स. मैं ये कह रहा हूं कि आपका रिजल्ट अप्रोक्सीमेटली 4% अवे फ्रॉम कोडल प्रोविजन होगा, क्योंकि आपने 4% मास मिस किया है.
तो फिर 4% मास लाने के लिए हमको मोड बढ़ाना पड़ेगा सर.
या दैट इज व्हाई फ्रॉम 20 यू हैव टू गो टू 91. और 91 से भी आपको बहुत ज्यादा फर्क नहीं पड़ता है. आपके रिजल्ट्स देखेंगे ना, तो हो सकता है यू आर डिजाइनिंग अ कॉलम फॉर से some lateral moment about 20 kilonewton at top. हो सकता है 91 के बाद you will have to say that okay, not 20, actually it is coming 21.1. तो क्या फर्क पड़ता है? यू कैन डिजाइन द कॉलम फॉर 25 kilonewton.
सर
या
सर इसमें सम यूएक्स और यूआई दोनों ही सर मतलब कोडल प्रोविजन के हिसाब से 90 से 90% से ऊपर होने चाहिए दोनों.
या some
Yes.
UX as well as some UI has to be more than 90%.
सर आपने एक मॉडल क्रिएट किया था G+5 का आई थिंक, तो उसमें आपने मोड नंबर आई थिंक 12 ही लिया था, तो उसमें हम लोग को 90% नहीं आया था.
हाँ, मगर आगे चल के वो आता ही नहीं था ना, तो इट वाज समथिंग नियर अबाउट 90. सी डोंट गेट blocked with that 90%. The psychology behind that 90% is that you are very very near to your exact solution.
एक वो ठीक है सर, बट सर मेरा कहना ये है कि अगर हम G+10 का बिल्डिंग क्रिएट करते हैं, एनालाइज करते हैं, तो उसमें हार्डली हम लोग 20 मोड ही ले सकते हैं.
No, you can go for, see, the software is analyzing, you are not analyzing. You can go for 1000 modes. Who is restricting you for that?
सर तो 1000
इलेक्ट्रिसिटी
सर 1000 मोड लेंगे तो फिर वो 90% लाने के लिए तो लास्ट हमको लगता है कि 900 पर वो मोड 90% आएगा।
नहीं see the 90% mass contribution does not depend on how many number of modes that you are using for your analysis.
ओके सर।
It depends on what is the behavior of the building, what is the structural configuration of the building, how many cutouts are provided over there, what is the orientation of the column, what is the size of the column, what is the size of the beam, how whether the columns are tied at every floor level or left untied, all that. So your structural configuration,
सर
it is
एक
a
क्वेश्चन और।
character. See, mode behavior is a character of the building and not how many number of modes that you are considering. See, that if you remember our PPT, in that PPT, even one mode was enough. It was passing 90%
Yes, sir.
because that building was very symmetrical
It's almost 92. First one.
in first mode itself. So you're basically you don't have to go for additional number of modes. That depends on the character of the building, not with the height of the building or number of floors. It depends on what is the configuration that you have adapted over here.
इट मीन सिमेट्रिकल होगा तो वन मोड में भी 90% आ सकता है, अगर अनसिमेट्रिकल होगा, अगर अनसिमेट्रिकल होगा तो वो 100 मोड पर भी जा सकता है।
हाँ,
ओके सर।
that is why you are going for dynamic analysis. See, when you cannot rely simply on static analysis, then for your further confirmation you are going for dynamic analysis. Okay.
Excuse me, sir. Excuse me, sir.
Yeah.
Hello.
Yeah. Yes.
Sir, actually, yes, sir, actually, what is the benefit we have by limiting these modes to 12 or
Your
12 modes
analysis. See,
than considering 90?
analysis. See that
What?
see why it was given earlier. We were not having software for our help. So earlier, if I want to go for so many modal analysis, I will have to go for that inverse matrix and all that, which is beyond human calculation efforts. So that's why that approximation was given by the code. Even if now we can say that if the 90% of the mass of the building is activated in few modes, then remaining 10% mass, we need not worry because then the building will provide you a sufficient distribution. See, the first thing is that why we are carrying out what we are understanding with that behavior. Okay, let me show you. Let's say this is your building. Why the building is vibrating? Concentrate on that psychology. When there is no earthquake, why the building is not vibrating? Because earthquake, if earthquake is hitting the base of the structure, it is providing extra energy. So in terms of potential energy, kinetic energy, so extra energy is given as input to your building. So any extra energy and sudden sudden extra energy is given to input of the building, the building gets excited and it start vibrating. And through the vibration, this sudden energy is released. Released. Earthquake will provide energy and vibration will dissipate energy. And as this sudden energy is dissipated, say 90%, the building will come to its stable position, so that we can say that okay, 10% vibration, that is okay, no problem. That's why we are finding out the dynamic analysis, that how whatever the extra energy given or given by the earthquake to the building, what this building is, how the building will dissipate that energy. If the building will dissipate that energy with torsion, so entire building start rotating like this, then column will get twisted, and the uh, columns will lose their strength, and building will collapse, right? That's why we are avoiding the torsional behavior. And why we are saying that first mode, second mode, and third mode should not be in torsion, because in the first three modes itself, majority of the energy is absorbed by the building or dissipated. The energy is dissipated, and that you can look into your analysis. Let us see that, so that your idea will get clear. Okay. Show tables and mass participation ratio. Why am I interested in mass participation? See here, for first mode. So if I go for first mode, second mode, third mode, fourth mode, almost more than 68% of energy is getting released in first four modes. So my building, or the deformation, adverse deformation in the buildings are reducing. So that's why in higher modes I'm not interested, because the energy is not dissipated that way. So if I go up to 20, so if I go up to 20, I can say that almost 85% and 87% mass is getting activated, and through that activation, the energy is released. So now the energy inside the building is only 10 to 15%, which I know that it can bear. Understood the psychology behind that? A little bit complicated, but this some UX and some UI will let you know that the earlier frequencies, lower frequencies, or higher time period, in that higher time period, building, if the building is not subjected to drastic translate torsional mode, then the probability of building getting safe during that earthquake excitation is increased. Clear? थोड़ा कॉम्प्लिकेटेड है.
नेक्स्ट क्लास में इसको देखेंगे सर आप.
नहीं, उसके लिए आपको अर्थक्वेक बिहेवियर मैंने आई हैव गिवन यू दैट बुक. व्हिच वन? यस, व्हिच वन बुक आई वाज टॉकिंग अबाउट?
Murthy.
Yes, CVR Murthy. Go
Yes, sir.
through that CVR Murthy book, and your entire concept will. See, don't go into the each and every minute detail, but overall thought, how the buildings are designed, so that we can say that my building is earthquake resistant. That has been explained very nicely in that, and without any mathematical calculation, because that mathematical calculation, once you come into the mathematical calculation, the boring thing starts. But conceptually understanding how, why I'm not interested, the building should perform torsionally, Even if the building is subjected to torsion, it will release the energy. Are you getting it? It will definitely, it will release the energy, but that release of energy will distort the columns, and because of that, building may get collapsed. That's why I don't want that thing to happen in the building. I am trying. See, just if you want to see the process, let's say that, uh, okay, let us say few of you are earning some 25 or 30,000 per month. So you are habitual with that 30,000. Kyonki you are earning every month you are getting 30,000, and with that you are expending that 30,000 for your living and betterment expenses. But suddenly, let's say one fine morning, you come to know through your email that some 10 lakhs rupees have been deposited in your bank account. Will you not get excited? Yes or no?
Yes, sir. Definitely.
And then what will happen? You will start expending that. Now, if you expend those extra 10 lakhs, which were not yours, in a good manner, then you will be praised by the people. And if you use that for some sort of racing, gaming, and in any other unwanted activities, you will get disturbed finally, right?
Yes, sir.
The same analogy applies to this building. Now, this building is prepared to restrain the potential energy due to bending or settlement or deformation. The building is habitual, so building does not get excited. But suddenly, this earthquake gives n times energy. That building is not uh, um, not habitual, so the building will start dissipating that energy. Now, if it is dissipating the energy in torsional mode, then the building might get collapsed. But if it is dissipating in the translation mode, then building will be stable. So, do you want your building to behave in torsional mode when extra energy is given to the building by some XYZ activity? Yes. See, one more analogy I will say that, see, if one fine morning you come to know that somebody has deposited 10 lakhs in your bank account, you get excited. But just think about Dhoni. One point morning, somebody lets him know that somebody has deposited some 2 crores or 3 crores in his account. He is not at all excited because he is habitual to spend that 1 crore or 2 crore every day, so he will not get excited. Okay, okay, somebody might have given. I'm working with n number of people. That's okay. Are you getting it?
Yes, sir.
So the same thing happens with the building. The extra energy that has been given as input to the building cannot sustain without getting excited, and that excitement we are training with our design. We are saying that, okay, if you get excited, get that energy dissipated in either in translation in x direction or translation in y direction, but don't dissipate the energy by rotating about vertical axis, so that you will not get collapsed, right?
Yes, sir.
So with this, I think it is time for today, because if I go ahead and then the things will be beyond your control. So let me know what you think about this analysis things. This is Exciting or not?
Exciting, sir.
Conceptually, see other mathematical details and all that things you will come to understand only when you are going through earthquake behavior of residential buildings. But conceptually, at least you will come to know why code is giving you that those guidelines. Not because code wants you to get trouble. Code wants your building to release the energy in a desired manner. Because we are using R equal to 5, that means we are already designing the building for lesser base shear. That means damage we are accepting. Now then, accepted damage must be in R defined way and not by any other way. Clear?
Clear, sir.
So R equal to 5, ductile detailing and earthquake behavior. These are the key points that will give you or that will assure the performance of the building. Okay, then with this, we'll conclude today's session, and in next session, we'll go and see additional clauses about drift and other base shear distribution, all that. Okay.
Okay, sir.
Thank you.
Okay, sir.
Okay. Okay.
Thank you,
Good night,
sir.
sir.
Thank you. Good night.
Thank you, sir.
Good night, sir.
Good night.
Good night.
Thank you, sir. Good night.
Good night.